Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this nice integral from 0 to pi over 4 natural log of tan of x raised to the 1 raised to the 1 2 3 4 5 6 7 8 9. So okay, let's generate this integral. So let's take integral from 0 to 5 over 4 natural log of tan of x raised to the, now instead of this number we can take m dx. Okay, then here tan of x, so I'm going to take a substitution. X is equal to arctan of u. Then we can differentiate. If we differentiate here dx, and here this side we have du over 1 plus u square. Then we can plug in. Now we know we should change the boundaries. So lower limit when x approaches to 0, we know arctan of, so here lower limit also 0, upper limit when x approaches to pi over 4, we know arctan of 1, so here 1. Then natural log of tan of x, if we take tan both sides, we know tan of x is equal to u. So we have natural log of u, and here raised to the m power, so we can write natural log raised to the m power of u. Here dx, dx we know du over 1 plus u square, so 1 plus u square, and here we have du. Okay, then here 1 over 1 plus u square, so 1 over 1 plus u square we can represent as an infinite series by using a sigma notation. We can write here integral from 0 to 1 infinite sum n is equal 0 to infinity minus 1 to the n times u raised to the 2 times n, and here we have natural log raised to the m power of u, then du. Well, now minus 1 to the n. Before it, now we can switch the sigma notation and integral sign. So we have n is equal 0 to infinity. Also minus 1 to the n, we know constant, so we can write outside of the integral sign minus 1 to the n power. Integral from 0 to 1. Now here we have u raised to the 2 times n times natural log raised to the m power of u times du. Okay, then let's take a substitution. Here we have u, so I'm going to take u is equal to u is equal to e to the minus t. Then we know t is equal to minus natural log of u. Then dt is equal to minus 1 over u times du. Then u we know e to the minus t, so we have dt is equal to minus 1 over e to the minus t times du. Well, now we can plug in here. Here infinite sum n is equal 0 to infinity minus 1 to the n. Now we know limit here 0 to 1. Now we have infinity to 0. Now u we know e to the minus t, so we have e to the minus 2 times nt times here natural log of u. We know natural log of u is equal to minus t, so minus t raised to the m power times then du we know minus e to the minus t times dt. Okay, let us simplify. Now here again sum of 0 to infinity minus 1 to the n. Here we have minus 1 to the m, so minus 1 to the m power. Now we can interchange these boundaries, like 0 to infinity. When we change the boundary, this minus sign get cancelled. So we have here e to the minus 2 times nt, here e to the minus t, so minus t we can take as a common factor. So we have here 2n plus 1 times t to the m times dt. Well, then here t times 2n plus 1, so I'm going to take another substitution. So we can take t times 2n plus 1 is equal to v. Then if we differentiate, 2n plus 1 dt is equal to dv. Well, let us substitute. So here now we have minus 1 to the m. We can write outside of the sigma notation, and here n is equal 0 to infinity. Here minus 1 to the n power. Now limit, if we change the limit, we know also 0 to infinity. Now here e to the t times 2n plus 1 v, so minus v times t to the m power. T we know v over 2n plus 1, so v to the m power over 2n plus 1 raised to the m power times dt. We can isolate the dt here, dv over 2n plus 1. Well, then here minus 1 to the m, here sum of n is equal 0 to infinity minus 1 to the n power. Now here 2n plus 1 raised to the m power, 2n plus 1, so we can take 2n plus 1 raised to the m plus 1, then integral from 0 to infinity e to the minus v times v to the m times dv. Well, now let us call the gamma function and Dirichlet beta function. Well, we know gamma function, gamma of c is equal to integral from 0 to infinity e to the minus x times x to the c minus 1 dx. So here this part we know now, this is equal to gamma of m plus 1. Then let's recall the Dirichlet beta function. In the previous video we also used beta of s is equal to infinite sum n is equal 0 to infinity minus 1 to the n power over 2n plus 1 raised to the s power. Okay, now here we have m plus 1 power, so we know this is equal to beta of m plus 1. So we have the answer minus 1 to the m times beta of m plus 1 times gamma of m plus 1. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.